Good evening, you pre-AP Precal Bearcats. I just want to go over a few examples from your assignment that was really the assignment for from last night, actually Monday night, October 1st. This was the first night of zeros of functions. I will try to go through that and the next night. If I don't get through both, then I will try to do that, continue to catch that up. So I'm just a little behind, but I will get caught up for you. Hope this helps. Alright, so I'm going to start, and I'm just going to go by example and explain as we go. We're going to start here on page 179, problem 15. The problem is h of t is equal to t cubed. Sorry about that. I'm going to erase and make that prettier. T cubed plus 12t squared plus 21t plus 10. And we're looking to find all the rational zeros of the function. So in this case, since we have 4 terms, we might be able to factor by grouping. But looking at this, there really is nothing common that we could factor out. We could maybe put the T3 and the 10 together and the T2, but even so, I don't look like that we can factor much out. So we're going to have to use all of our little methods that I don't know if you remember from last year, but hopefully you do. The first thing we're going to do is we're going to talk about the possible rational roots. So the possibilities, these are called possible. Okay, so we're going to find these possible rational roots. And what that really means is the possibilities, the things that are possible solutions to this polynomial. So the first thing I'm going to do is we're going to use our p's and q's, and hopefully you remember this from last year. Remember, our p value will be our constant, and our q value is the coefficient in front of the first term, the greatest term. So or the leading coefficient. So p would be 10 over, and it's factors of 10 over factors of, in this case, 1. And it's positive and negative. So factors of 10 would be 1, 2, 5, and 10 over factors of 1, which is just 1. And they're the positive and negative values. So again, you would have positive or negative 1, positive or negative 2, positive or negative 5, and positive or negative 10. So that's basically 8 possible rational solutions. Alright, so 8 possibilities. Alright, so then we're going to use synthetic division to try to find one. Once we find a solution, then we have a quadratic, and you can solve that quadratic by other methods, which could be quadratic formula or etc. Don't forget also that you could have something called multiplicity. You could have something more than once, occur more than once. So let's go ahead, and we're going to do synthetic division, which means we use our coefficients. In this case, that would be a 1, a 12, and that's a cubed, a squared, and just a plain x term, and a constant. So we have 21, and we have 10. If you skip over a term, then you're going to have to hold its place with a 0. Okay, so let's do synthetic division. I like to use this little chart where we can just keep going synthetically. We could try 1, positive 1. Let's just do that. We pull down the first term, that's 1. 1 times 1 is 1. 1 and 12 would be 13. 1 times 13 is 13. 13 and 21 would be 34. 1 times 34 is 34, plus 10 would be 44. Alright, so not a 0 because it doesn't equal 0, but it is an ordered pair on our graph, and I don't want you to forget that. So that ordered pair would be the x value of 1 and the y value of 44. Also understand, if I were to plug in 1 into my equation for all the t values and I totaled up, the value would be 44. So it's the same as plugging an x value in. So let's try negative 1. Okay, remember I'm using these values right up here. I'm going to kind of keep them. Sometimes I'll ask you to highlight those values. If you highlight those values, it kind of reminds you to keep using those over again until you find a 0. So I'm going to use negative 1. So I bring down the 1 from up here. Negative 1 times 1 is negative 1. Negative 1 and 12 is 11. Negative 1 and 11 is negative 11. Times negative 1 times 11 is negative 11. Negative 11 and 21 is it's positive, positive 10. And negative 1 times 10 is negative 10, and 10 is 0. All right, zeros get us happy guys. All right, so we have a happy guy. That means that at negative 1, 0, we have an x-intercept, or a solution, or a root to our polynomial. We also now have reduced the degree of our polynomial from third degree to quadratic. So this is now the quadratic that we could write from this. And we know that this is a solution. So let's highlight that for a minute. That's a solution. So now we have x squared plus 11x plus 10. Now, could we factor that and get our other solutions? Let's think about that. 2 and 10, that's not going to give us 11. 1 and 10, though, would. So let's try that. So if we do that, we would have x and x. We'd have 1 and 10, positive and positive, equal to 0. So our solutions here would be negative 1 and negative 10. So our other two solutions, and we would have three solutions because we had a cubic. We had a third degree polynomial. So our solutions then are x equals negative 1, and that's twice. We don't need to write it twice, and negative 10. Negative 1, because it happened twice, has what we call a multiplicity of 2. And in a graph, what that means is it touches at that point and goes back up, or touches and goes back down. We'll talk a little bit more about that when we get to graphing. All right, let's go on. The next problem we're going to work is problem number 19. Problem number 19. 19 is f of x equals 9 x to the fourth minus 9x cubed minus 58x squared plus 4x plus 24. Oh wow, that's big. All right. Are they all divisible by 9? No, unfortunately 4 is not. Neither is 24, so we can't do that. So again, we're going to use our possible rational roots. So P's and Q's. So it's going to be positive and negative factors of 24 over positive and negative factors of 9. Oh boy, we're going to have a lot of possibilities. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And the factors of 9 are 1, 3, and 9. Alright, so we have lots of possibilities. Everything over 1 gives us the top list. I'll repeat that. 1, 2, 3, 4, 6, 8, 12, 24. And then it gives us everything over 3. So 1/3, 2/3, 3/3 is 1, but 4/3, 6/3 is 2, 8/3, 12/3 is 4, and 24/3 is 6. So we're done with that, or 8, sorry. Then we go over 9. So we'd have 1/9, 2/9, 3/9 is 1/3, which we've already written, 4/9, 6/9 reduces to 2/3, which we've already written, 8/9, 12/9 will reduce to 3 goes into there, 4/3, which we already written, and then of course 24/9 will reduce to 8/3, which we've already written. So those are our possibilities, and it's all positive and negative. Positive and negative. Let's look for just a minute at Descartes' chart, which may also help us. That's our positive, negative, and complex imaginary solutions. We know in this case that we have a total, and I like to write T for total. A lot of people don't write the total. But we know we have a total of 4 possible solutions, or 4 solutions, because it's a 4th degree polynomial. Let's look at our sign changes. If we took the original equation, I'm going to erase this P and Q real quick, just so we can see, make it a little cleaner. If we took the signs that were here, the first term is positive, the second term is negative, negative, positive, and positive. And we're 4, 3, 2, 1, 0. So how many times does it change? It goes from positive to negative, that's 1, back to positive, that's 2, and it stays. So twice. So we could have 2 sign changes or decrease by 2, 0. So we could have 2 positive solutions or no positive solutions. Let's talk about our negative changes. If we plug a negative in for x and we go to the fourth, it's positive times 9. That entire would be, I'm going to write it in here, that would be a positive term. If we take a negative and cube it, and then we multiply by a negative, we would have a positive term. If we take a negative and square it, we would have a positive times a negative is a negative, negative times positive is a negative, and a positive. So again, here we have 1, 2 changes. That doesn't help us much. When we add straight across, this would be 0, this would be 4. Now, because we have 2, 2, 2, 0, we could also have 2, 0, or we could have 0, 2, and 2 complex imaginary solutions. Unfortunately, this chart this time does not give us a great deal of insight. Our lower and upper bounds chart might have been more helpful, but sometimes this can be a really helpful chart. And this chart is called Descartes' rule of signs. So it might be helpful. Kind of took that out of the way. All right, we've got all these possibilities. I don't want to just start randomly deciding what to divide by. So let's go ahead and just go with our lower and upper bounds chart. Sometimes that's really helpful. And again, that's just the little chart we were doing a while ago. The one we were doing a while ago. And hopefully something will come up soon. Let's start with our coefficients, which are 9, negative 9, negative 58, 4, and 24. And we'll start dividing first. That's 0. So 0, 24 is our y-intercept. And then we'll start dividing by 1. So we bring down the 9. 1 times 9 is 9. 9 and negative 9 is 0. 0 and negative 58 would be negative 58. Negative 58 and 4 is negative 54. Negative 54 and 24 would be what? 30. Negative 30. Okay, so we would have 1 and negative 30. Look what happened. If you look, we had a sign change. We went from positive to negative. If you looked at a graph, and I'm really just quickly sketching, and we're at 0, 24, and then we're at 1, negative 30, we had a crossing. So we crossed at some positive fractional value. Now, we could start going through all these fractions, and we might need to do that at some point. But we could try to look for a fraction to find an answer. To save us a little bit of time, I'm going to let you know, because this video takes too long. If you tried 1/3, 1/3 would not work. But let's try 2/3 and see what happens. So if we try 2/3, we bring down, remember, once again, we're using this top row of numbers because we never found a 0. If you find a 0, then you can use the new row of numbers. So we bring down the 9. And then we have 2/3 times 9. Well, 2/3 times 9, 3 goes into 9, 3 times 2 would be 6. So we would have, this would be, multiplied would be 6. 6 and a negative 9 would be negative 3. 2/3 times negative 3 gives me a negative 2. Negative 2 and negative 58 would be negative 60. 2/3 of 60. Well, that would be 3 goes into 60 20 times. And negative 20 times 2 would be negative 40. Negative, let's see if that's right. 20 times 2 would be negative 40. Alright, so negative 40 and 4 would be negative 36. And finally, 2/3 of 36. 3 goes into 36, 9, and, no, 3 goes into 36, 12, and 2 times 12 is negative 24. Negative 24 and positive 24 give me a 0, and we get the happy guy. Alright, so one of our factors now, one of our solutions is 2/3. That's one of our solutions. the next thing we're going to do is we're going to, we know we're going to have two positive solutions or no positive solutions. Since we have one positive solution, we have to have another positive solution. So I'm going to go back and go away from the fractions for a minute and go back and try a couple other things. We're now going to be using this new row right here. And there are several approaches we could have taken to this. So this is not the only choice of numbers. I just kind of shortcutted when I knew it was 2/3. So if we take this new group of numbers, remember if we can reduce one more time we'll have a quadratic and we can solve by other means. We take this group of numbers and we try 2, positive 2. So we bring down the 9, we get a 9. 2 times 9 is 18. 18 and negative 3 would be 15. 2 times 15 is 30. 30 and negative 60 is negative 30. And 2 times 30, negative 30 is negative 60. Negative 60 and negative 36 would be, negative 60 and negative 36 would be negative 66. Oh, sorry, 2 times 30 is negative 60, and 36 would be negative 90. Sorry, 96. 30, 60, 70, 80, 96, yeah. All right, negative 96. So we're at 2. So at 2, we're way down here further. So we haven't started coming back up yet. But we know we have another positive value because our chart over here tells us, okay, this chart tells us, and also we've got to come back up because our graph rises on the right because it's a positive 9. So we know we have to come back up. So let's try one more round at using 3. And we're still on this row right here. We're still going to use this row of numbers because we didn't find a 0 this time. So we bring down the 9. 3 times 9 is 27. 27 and negative 3 would be positive 24. 3 times 24 would be 72. 72 and 60 would be positive 12. 72 and negative 60 would be positive 12. And 3 times 12 is 36 and negative 36, woohoo, is a 0. Happy guy. Maybe we'll get a party girl this time. All right, so we now have a quadratic that we'll be able to solve, and we also know that 3 is our other positive solution. We have 4 solutions. We found 2 positives. I'm guessing we're going to find 2 negatives. Or I guess we could find 2 imaginary. Let's check it out. So we have a quadratic. We have 9x squared plus 24x plus 12. You could factor out a 3 out of everything if you wanted. Just divide everything by 3. Makes the numbers a little easier. We would have 3x squared plus 8x plus 4. And then you could factor, or we could use the quadratic formula. I'm going to go ahead and practice the quadratic formula. I know it's longer, but since we have coefficients, I'm going to do that. So I know my A is 3, my B is 8, and my C is 4. So I have negative B, which would be negative 8, plus or minus the square root of B squared, which would be 8 squared, plus 4 times A, which is 3, times 4, which is C. All over 2 times A, which would be 2 times 3. So, with that being said, I'm going to come over here to the side. We would have negative 8 plus or minus the square root of a number. That underneath there is the discriminant, all over 6. Okay, and so when we find the discriminant, that's going to be 16. So now we know we have negative 8 plus or minus 4 over 6. Negative 8 plus 4 would be negative 4. Negative 4 over 6 would be negative 2/3. Negative 8 minus 4 would be negative 12. Negative 12 over 6 would be negative 2. So there are your other 2 solutions. So you would have negative 2/3 and a negative 2. So those would be your solutions to that polynomial. All right, let's move on and take a look at problem 29. Actually, those are kind of lengthy. This won't be quite so long. This just asks us to list all the possible zeros and then find the real roots, the zeros of the roots. Actually, you can do this from the problems I just did. So let me look at problem 39. Let's look at problem 39. All right, 39 gives us 6, negative 5, plus 2i, and negative 5 minus 2i. And ask us to find the polynomial with these coefficients, with real coefficients, sorry, that have these zeros. Okay, they have these zeros. So, if these are our zeros, then these are the solutions to the factors. We need to first write as factors. So if your solution is 6, your factor was x minus 6. If your solution is negative 5, then your factor was, then your factor was x plus 5 plus 2i. And your other factor would be x plus negative 5 minus 2i. Negative 5, not negative, sorry. 5. Yes, negative 5 minus 2i, sorry. So those would be your factors. And now we would need to multiply all those out. I'm going to multiply these together first. This is going to be the one that takes us a while. So if we do this, we would have x times x, which is x squared. We would have x times negative 5, which would be negative 5x. And we would have x times negative 2i, which would be negative 2ix. And then we would go with the 5. 5 times x is positive 5x. Alright, immediately I'm going to mark out the negative 5x and the positive 5x. Okay, those really just are going to go away. Alright, let's keep going. And then we have 5 times negative 5. That's negative 25. And we have 5 times negative 2i, which is negative 10i. Alright, and now last let's go to the 2i. 2i times x is positive 2ix. And that's going to go away with negative 2ix. We have negative 2ix is gone, that's all gone, and positive 2ix is gone. Then we're going to go 2i times negative 5. That's negative 10i. Oh, here we go again. So we have negative 10i and negative 10i will be a positive. So that's not gone yet. Alright, and then last we're going to have 2i times negative 2i. That's negative 4i squared. I squared is a negative 1 times a negative 4 just means that's going to be a positive 4. A positive 4. Alright, let's keep going. I'm going to go back here just a minute. I apologize. When I wrote these, I got a little messy in my work. So I'm going to erase that and go back to how we write those factors. I know that's really annoying. I apologize. And I would do the whole thing over, except I'm pretty tired. I don't want to do the whole video over. So I'm going to go back. Something just didn't look right. So I'm going to go ahead and say that this is an answer and this is an answer. Be really careful when we write those. So when I write this one, I would have gotten x. And because that's a negative, I would have said minus, or plus, I'm sorry, since that's a negative 5, it would be x plus, I'm going to put in parentheses, negative 5 plus 2i. And then I would have had x, and that's a negative, so it would be plus, but it would be 5 minus 2i. Oh, it's not a positive. Sorry, that's not a positive. So it would be plus 5. Oops. 5. And this would be plus 5. So what you should have had is x plus 5 plus 2i. And you should have had x plus 5 minus 2i. And I think I wrote that wrong a while ago. Alright, let's keep going. Sorry. So we have x times x is x squared. We have x times 5, which is positive 5x. We have x times negative 2, which is negative 2ix. Then we go 5 times x and we have positive 5x. And then we go 5 times 5 and we have positive 25. And then we go 5 times negative 2i and we have a negative 10i. So really nothing's canceled yet. Now we're going to go 2i times x, which is positive 2ix. That is going to cancel with negative 2ix. So we're going to cancel those out. Then we're going to go 2i times 5, and that's going to be a positive 10i. And our i's will cancel out again. And then finally, we're going to go 2i times negative 2i, which is positive 4i squared. Or sorry, negative 4i squared. Boy, I am tired tonight. Sorry about that. So negative 4i squared. I squared would be a negative 1, changing this 4 to a positive. And so we're left with the terms to combine. So we have an x squared. We have 5x and 5x, which is 10x. We have a 25 and a positive 4, which is going to be a positive 29. Now, we have to still multiply all of that by x minus 6. And let's do that. We just have to be really careful when we do these. So we have x times x squared, which is x cubed. We have x times 10x, which is positive 10x squared. And we have x times 29, which is positive 29x. Then we have negative 6 times x squared, so we have a negative 6x squared. I'm lining them up so it's easy to combine them. We have a negative 6 times 10x, we have a negative 60x. And finally we have negative 6 times 29, and I believe that will be a negative 174. Negative 174. Alright, now we're going to combine like terms. Just going to draw a line and do that. So we bring down, we have x cubed. We have a positive 10 and a negative 6. We have a positive 4x squared. We have a positive 29 and a negative 60. We have a negative 31x minus 174. That is our final answer. Go Bearcats. Alright, I was going to do one more problem. Let me see what that was. I believe that was problem 59. Let me look and see if that's necessary. Find all the zeros of the function. Write the polynomial as a product of linear factors. Yeah, let's go ahead and do that. So this is problem number 59. 59 is f of x equals x to the fourth minus 81. So we're going to find the zeros, and then we're going to write all the factors. Well, to find the zeros, we're going to just set it equal to 0. We would move 81 to the other side, and we would have x to the fourth equals 81. That's one method. Or you could have done this. You could have factored. And I really like the factoring part because sometimes you forget that these are perfect squares. The base of this is x squared. The base of this is 9. So if you factored that, you would have had x squared plus 9 and x squared minus 9. Then you could have factored this one again. The x squared plus 9 you really can't factor again because it's positive. But this you could have factored into x plus 3 and x minus 3. So your solutions would have been 3 and negative 3. And then here you would have to set x squared plus 9 equal to 0. X squared equals negative 9. Square root. You are an artist, but you have that negative. You've got to pull out an I. So you would have had x equals plus or minus I square roots of 9, which is 3. So basically 3i. So we would have had positive or negative 3i. Those are your solutions. To write them as factors, you're going to write all the factors. Well, regardless of how you find your solutions, you can always go back and write the factors. The factors are right above us, but let's talk about if you started with a solution. Since this is positive 3i, you would have had x minus 3i. If this is a negative 3i, you would have had x plus 3i. This is a negative 3, so you would have x plus 3. And this is a positive 3, you'd have x minus 3. And that is your product of linear factors. All right. Good night for tonight. I will do a little bit more tomorrow, and I will keep going for you. Have a good evening. Bye.